When we think about risk in software, our minds usually jump to things like bugs, system crashes, or maybe some security holes. But with artificial intelligence, the whole rulebook gets tossed out the window. Managing risk for AI isn't just a small step up from what we're used to, it's a completely different ballgame. So let's dive in and break down exactly why.
All right, to really get it, you got to see the difference between the two types of code. On one side, you have traditional software. It's like a perfect recipe. It's deterministic. You follow the steps, you get the exact same result every single time. The logic is totally transparent. But then, there's AI. And it's probabilistic. It's more like a master chef tasting ingredients. It learns from data to make predictions. Its behavior isn't explicitly programmed, it's learned. This makes it dynamic, always changing with new data. And the logic? Well, it's often a total black box, making it almost impossible to know precisely how it cooked up a specific decision.
And that huge difference, that leap from predictable instructions to unpredictable learning systems, it forces us to zoom out and think way bigger. See, AI doesn't just live on a server somewhere. It's out here in the real world, interacting with all of us, with society, in some really profound ways.
There's actually a great term for this from the NIST AI risk management framework. They call it a socio-technical system. Now that might sound a little academic, but all it really means is that the risks and the benefits don't just come from the technology itself. They emerge from that messy, complex interplay between the tech and us, society. It's not just about the algorithm, it's about what happens when that algorithm gets into our hands.
So what does this mean in the real world? Well, it's crucial. The social environment an AI is dropped into literally shapes its behavior. The biases that we humans have, if they're in the training data, they get baked right into the system's performance. And the ways people actually end up using the system can create totally new risks that the developers never even dreamed of. So suddenly we're not just dealing with tech problems, we're forced to grapple with massive issues like human rights, the well-being of our communities, and even the environmental cost of it all.
And that leads us to one of the most unique and tricky risks in the world of AI. Since these systems learn from data, they are completely dependent on it. But what happens when that foundation, the very ground the model is built on, starts to shift under its feet? Here's a good way to picture it. When you train an AI, you're basically showing it a single photograph of the world, frozen at one specific moment in time. All its knowledge, every pattern it recognizes, is based entirely on that one snapshot. And of course, there's the catch. The world doesn't pose for a picture. It keeps moving. The way we shop changes, we invent new slang, the economy goes up and down. That perfect little snapshot the AI studied, it gets old, and it gets old fast. This exact phenomenon has a name: data drift. It's what happens when the real-world live data an AI is seeing starts to look statistically different from the old stale data it was trained on. All the patterns it learned just don't match reality anymore. The fallout from data drift is no joke. It's immediate and it can be severe. The system's performance just tanks. The model gets stale, making its predictions less accurate and way less valuable. But most importantly, the chance of it making errors that have negative impacts on real people just skyrockets. This forces teams into a never-ending, costly cycle of just trying to monitor the system to keep it from flying off the rails. But look, unstable data is only part of the story. Even if we could magically have perfect, unchanging data, we'd still be facing another monster of a challenge: the sheer, mind-boggling complexity of the AI model itself. This is the problem of scale and opacity. To give you a sense of what we're talking about, modern AI systems can have over 1 trillion parameters. Think of each one as a tiny little decision-making knob. 1 trillion of them. That number is so vast it's hard to even comprehend. So the idea of manually checking every possible outcome, it's physically impossible. That is the scale of the challenge we're facing.
This massive scale creates some huge built-in problems. The internal logic becomes so opaque, so inscrutable, that sometimes even the people who built it can't tell you exactly why it did what it did. And that makes it a nightmare to measure risk or to debug things when they go wrong. We're also still figuring out how to properly test and document these things, and we can't forget the colossal environmental cost of the power needed to run these behemoths.
This all leads us to a really strange paradox in how AI gets built today. It's a situation where the very shortcut that speeds up development can also become a massive amplifier for risk. This happens through a process called transfer learning. Instead of building a gigantic model from scratch, which is incredibly expensive and time-consuming, developers often take a powerful pre-trained model built by someone else and just adapt it for their own specific task. It's a huge, huge shortcut.
Now, the promise of this is pretty clear. It makes development way faster, it can improve accuracy, and it lets smaller companies get in the AI game. But the peril is just as big. You're inheriting a black box. This adds a ton of statistical uncertainty and makes it nearly impossible to fix any biases that were baked into the original model. It even opens up new security holes, like data poisoning, where an attacker could have intentionally corrupted the original model, turning it into a time bomb you just put inside your own product.
Okay, so let's just recap for a second. We have dynamic systems built on ever-shifting data. They have opaque, black box logic, and they're often built using pre-made components from sources we don't fully control. When you put all of that together, it becomes undeniable. Our old frameworks for managing software risk are just not equipped for this new reality.
And hey, don't just take my word for it. As NIST puts it directly in their AI risk management framework, the risks posed by AI systems are, in many ways, unique. This isn't just a small update. It's a paradigm shift, and it demands a whole new approach.
So that new approach is laid out in frameworks like the one from NIST, which breaks the process into 4 key actions. It starts with govern, which is all about creating a culture that takes risks seriously. From there, you map out the context and identify all the potential risks. Then you have to continuously measure to assess and track those risks. And finally, you manage them by prioritizing and taking action based on their potential impact. And this really leaves us with the ultimate question, doesn't it? Our traditional rules were all built for static, predictable systems. So as AI gets woven deeper and deeper into the fabric of our society, how do we build guardrails for something whose very nature is to constantly learn and change in ways we can't always predict?